We have done so many IBMs in a row on this channel, so let's restore a clone today. This is first generation PC clones from Commodore, the Commodore PC10-II to be specific. There was also the PC5 and the PC10-I. They are identical except for the drives and the graphics cards. According to Wikipedia, this machine was sold with two 360K Chinon drives, but no hard drive. So previous owner seems to have swapped one of the Chinon drives for a hard drive. It also had a graphics card with MDA, CGA, Hercules and Plantronics. In this video we are going to restore it, and of course we're going to see if we can overclock it. This machine came with a badly yellowed Model F copy. It's actually a decent keyboard with Cherry MX black switches. I left some notes on this machine when I bought it years ago. Apparently this machine posts and then power cycles. So that doesn't sound too good. Let's hope this doesn't turn into a never-ending project like the cursed Commodore PC10-III that I have been struggling with since forever. Unlike the much smaller PC10-III, this machine is about the size of the original IBM PC. At the back here we have one display connector, one serial and one parallel port. And apparently we have a couple of screws hiding away underneath here too. I don't remember much about this machine, but I think the cover comes off without the front panel. And it does. Okay, we're off to a good start. I think this is the original graphics card. We also have what seems to be an MFM controller and a RAM expansion board. And indeed, there is a hard drive in this machine, but it has been disconnected. So that's not a good sign. Let's start by removing the cards. Yep, that definitely looks like the original card. So let's see what this guy here is. That is a very short controller. Let's see what this is. Okay, so this is an AMTECH branded controller. This guy here is labeled 408106-00 and Rev G. Next we have a RAM expansion card. This card is not installed in ISA slots. Instead, it has its own special slot here. Well, it doesn't say how much RAM it has, but the board should have 256K, and this machine was sold with 640K. So you can do the math. The power connector looks identical to the PC10-III, and I think the PC35 too. The parallel port is on the motherboard, but the serial port is screwed to the back of the case and connected with a cable to the motherboard. Let's pull that power supply off next. So place your bets. We're going to find some refuzz inside here. Quite likely. Okay, and it's out. Just like the original IBM PC, these boards don't have any real-time clock. That means no leaky VARDA. The connectors for the speaker and what I presume is one of the front panel LEDs is not marked. We also have the connector for the keyboard in the front panel here. The case is quite grimy, but inside this Commodore everything is actually quite clean. So I think I only need to wash the case. Let's pull that floppy drive out next and see what's hiding away underneath. I'm gonna guess it's an ST225, but who knows, it could be something odd. It kind of looks like the hard drive should have been installed in this position here, but there are only screw holes on this side. So I wonder if something is missing here. Maybe a second drive cage. Okay, let's pull that drive out. And it's actually not an ST225. So I was wrong. This is actually an ST238R. So this is no regular MFM drive. This is an RLL drive. That must mean that this is an RLL controller. I'm not sure if this is a good thing, because I don't have a spare drive in case this one is bad. So fingers crossed. Let's hope this drive is still good. Let's pull that speaker out next and remove the screws for the front panel. With the front panel removed, we can now access the keyboard connector that is on the front of the machine. Unlike pretty much every other machine, that has the connector at the back. And now we only have the motherboard left. So let's get that board out. It's installed with 2 screws and some of those extremely annoying plastic clips. Okay, I checked underneath and we're supposed to pull that motherboard forward. I should come off those plastic clips, but they're of course still stuck. Okay, and here's our motherboard. The motherboard has a rather odd shape, and the reason for it is because the RAM expansion card fits perfectly in here. So they basically made both PCBs in factory and then cut these tabs off and removed the RAM expansion card and installed it here instead. Now the weird thing is, why didn't they just leave the RAM here? Removing it and installing it in this position doesn't make any sense at all. Maybe they were planning to sell them without extra RAM. But in that case they could have just left the board without these chips installed. What a strange design choice. We are of course going to take a close look at the motherboard. But first, let's see what we will find inside the power supply. We've got those golden caps. I have been told that they are really good, but one of these blew up in my 5154, so I'm not sure if they are. Well, I guess they could be great caps, but being this old, I guess they could still go bad. But hey, we have no Riffa caps. These green guys are some other brand, so we're not going to get any magic smoke today. This power supply also has a really fancy fan. This guy here is made out of die-cast aluminium. It looks very similar to the fan we found in a Naboo. The floppy drive is indeed made by Chinon, so this is most likely the original drive. A small correction here. The earlier PC10 doesn't have the same motherboard as this PC10-II. They have the same specs, but they actually made 2 different motherboards. This board is quite different from the later PC10-III. I haven't checked every single chip here, but it seems to have been made out of standard components only, just like the original 5150. So for instance, there is no Faraday chip on this board. That's actually a good thing, because if it ever breaks down, it should be easier to find parts. The graphics card actually turned out to be quite interesting. This is the earliest ATI card on Wikipedia, and apparently it's called ATI Technologies Graphics Solution Rev 3. And sure enough, it can do MDA, CGA and Hercules. One interesting feature this card has is that it came with a utility, vset.exe, that allows the user to switch between CGA and Hercules without requiring reboot. So that's pretty cool. So now we only need to find some information about those switches. I also found a thread on Vogon, and apparently this card can do Plantronics Color Plus too. I found the manual for the PC10-II and set these switches accordingly. So if this is the original card, they should now be set for Hercules graphics. Okay, I connected the power supply, graphics card, IBM 5151 display, the RAM expansion card and a speaker. Time for the first test. Fingers crossed. Okay, the fan spun up in the power supply and we've got graphics. Holy cow, that is a noisy fan. Let's see if it makes less noise on its side. Still quite noisy, but this is much better. Okay, so Commodore PC BIOS Rev 2.01, copyright Commodore Electronics Ltd. And it made a Commodore PET sound. Awesome. No scan code from keyboard, and that is of course because it's not connected yet. And then we've got 640k of RAM. Drive A bad, and it's of course disconnected too. Okay, awesome. It passed the first test. I won't be able to restore the keyboard in this video. So let's try with the proper FXT. No scan code from keyboard. So it doesn't seem to be compatible with a regular FXT. Let's try F1. Well, actually I did something. Boot disk failure. Type key to retry. No, the enter key isn't doing anything. Let's try the floppy next. I'll start with a cleaning disk. Let's turn the machine on. Okay, now the enter key works. That's strange. Okay, so maybe it needed a drive to give me a new disk boot failure. I'm gonna run this a few times and make sure those heads are clean. Okay, let's try with PC-DOS. See if it will read that disk. I switched to the original keyboard. Let's see if that's enough to get rid of that error. Love that Commodore PET sound. It's awesome. Okay, so we got a disk boot failure. That sucks. But the keyboard error went away, so apparently it needs this original keyboard. I actually also have the matching fluorescent green display for this machine, but I can't find it. It has been swallowed up in storage. But I guess I'll bring it out and we'll restore it together with the keyboard in another video. But it doesn't read the floppy, so that kind of sucks. It spins, but the heads are not moving. Okay, let's flip that drive and see if those heads are stuck. No, they're not. They are moving freely, so that's not a problem. Let's move the heads to this position here. And when we start the machine, the heads should go back to track 0. If that stepper works. Let's turn the machine on. Okay, the heads made a very small movement. It's counting up the RAM. And it's taking its time. Okay, now the heads are moving. Oh, and it reads. So they were stuck. Yes, it boots. And we are in DOS. That is awesome. So the heads were just a bit stuck. Perfect. Since the drive was disconnected, we better take a look inside before we turn it on. Just like the floppy drive, these old hard drives can sometimes get stuck when they have been in storage for a long time. So let's pull that lid off. Okay, well the platters look good, so that's a good start. And I can't see any mechanical issues. Let's gently turn those platters and see if it makes any noises. No, it's dead silent. So I'm gonna put that lid back on. Okay, keep your fingers crossed. Let's see if that drive spins up. It does. And it's not making any noises. It actually sounds really good. I love the sound of these old drives. Oh, I still have the floppy in the drive. So system boots from the floppy. So let's type C:, and enter invalid drive specifications. Okay, well that sucks. So no access to the data on the drive. I did a Google search on the controller, but I found nothing. Just a few listings on eBay. So the only option we have is to low-level format that drive and hope for the best. Here goes. Well, that doesn't look too good. Let's check and see if those heads are moving at all. Yes, they are. Yeah, that definitely looks good. So there's a good chance that this drive is working. So it's definitely worth trying some more. Well, in that case, let's try SpeedStore. And this is version 603. SpeedStore is recognizing one drive. So all is looking good here. Let's go for normal setup. And initialize. And standard init. Well, we don't have a choice. It seems to be damaged already. Well, the label on the drive actually states that this drive doesn't have any defects. So I'm gonna go for no. And I'm gonna go with the recommended interleave 5. But we'll check it later and see if we can go with a better option. Initialize. Okay, fingers crossed. At least the hard drive is correctly recognized as the 31 meg drive. 615 cylinders, 4 heads and 25 sectors. Okay, I skipped ahead a couple of minutes here. The hard drive sounds good and it has found a few defects here. But this list is pretty reasonable for a drive this age. But let's hope this is all it will find. Okay, we're doing pretty well. Skipped ahead about 4 minutes. That is all it found. So that is a very reasonable amount of bad sectors. And SpeedStore is asking if we want to add them to the bad track table. And we certainly do. Bad tracks are being marked. Oh no! We've got a seek operation failure. Let's go back and go to the defects manager instead. Do a surface scan. I haven't messed around with RLL drives. I think it's the same procedure as with regular MFM drives. Okay, we've got some weird stuff going on here. I cleared the lists and ran the tests again. And now we don't have any defects anymore. So that's a bit odd. Let's try to initialize again. Unfortunately, the graphics just started to misbehave. It's moving slightly up and down. I'll zoom in so you can see. So maybe it's time to recap my 5151. Let's go with standard and hit yes. No defects to enter. We're gonna go with this into leave for now. And initialize. And unfortunately, here comes the errors. Kind of strange that they weren't found when we searched for them. But when we initialized the drive, they all popped up again. I just realized this is actually not a standard Type 3 drive, as recognized by the system. I don't remember what all the standard types are, but it's hardly an RLL drive. So let's choose the drive manually instead. Go down to Seagates. And here's our ST238R. And indeed, the specs are not identical. We've got 26 sectors and not 25 as suggested. So let's hit enter, defects manager, delete the lists, and scan the surface. Well, it actually still says 25 here. So what the heck is up with this? But we do have the correct drive in the list now. So let's just run with this and see what happens. Okay, finished. We got a list of defects, but the list is different. So we don't have a bad track at track 0 anymore. That could actually make the whole difference. So let's go back and try to initialize again. Okay, let's hope this works. And the list is actually longer now than it was before. So it is behaving a bit strangely. Okay, let's add these defects to the list. We've got that same error. For our next test, we need a 3.5-inch diskette drive. So let's see if this board is compatible. We also need a Molex adapter. Okay, drive attached. Let's try with this fake double density disk. Drive A bad. Well, that kind of sucks. That would have been a really nice upgrade. I think the original XT can handle a 3.5-inch diskette drive, at least with double density disks. The reason I wanted to do this upgrade now is because I only have spin rights on 3.5-inch diskettes. But luckily I have a 360K drive in my PS1, specifically for stuff like this. So I used it to make a copy of SpinRite 5.0 on a proper 360K disk. So let's see if SpinRite 5 works with Hercules graphics. It does, awesome. Okay, and SpinRite is going to run a bunch of tests here. Okay, hard disk controller test passed. That's a good start. Oh no, it didn't detect the hard drive. It can't see that drive at all. So SpinRite wasn't much of a help. Well, that was a fail. Well, let's try IBM's Advanced Diagnostics 2.2. Okay, let's go for system checkout. Well, this list actually isn't quite correct. It thinks that we have 2 diskette drives and a printer, which we don't. But the important thing here is that it recognizes we have 1 fixed disk drive. So I'm gonna hit yes and run the tests 1 time. And then I'm gonna type 17 for fixed disk drive. And option 2 here to format the disk. And that is of course our C drive. Yes, I'm sure. Okay, fingers crossed. Well, I took a break and came back to this. I haven't used the software in a while, but I think this means it did a successful low-level format. Although it doesn't actually say. So let's exit and end and boot. I'll run fdisk. Oh, okay. I'm not sure if I got it on camera, but I tried to start fdisk earlier, but it couldn't find any disks. Let's see if we can create a partition. Create primary DOS partition, and yes we do. System will now restart. Insert DOS diskette in drive A. Wow, I think this might actually be working. The clone, saved by IBM. That is hilarious. Okay, and now the real test. Oh crap, apparently I don't have format available on this floppy. Well, that's an easy fix. Okay, new DOS floppy in the drive. Here goes. Well, it's doing something. Unbelievable. Format complete. I think we just saved one of many clones that eventually killed off IBM with IBM software. Yeah, it totally writes to the drive. So, I guess the final test is to see if it boots. Oh wow, it boots! Wow, this is nuts. Why didn't SpeedStore or SpinRite work, while IBM's original software for the XT worked? I have no explanation for this. This is just weird. But hey, hard drive works, so I'm happy. Let's just list that directory. Yep, totally works. Okay, the next test is to see if this motherboard is compatible with 1.2 meg drives. I rarely use 1.2 meg floppies, but since this board isn't compatible with 3.5 inch diskettes, this would be our second best option. Drive A bad, so that is a fail too, but not unexpected. I read somewhere years ago that fdisk in later versions of DOS can handle drives with defects much better than earlier versions, so made a special bootable floppy from DOS622, and on here we've got fdisk among a few other useful things. Since we know we probably have some defects on this drive, I'm going to delete that partition. I'll reboot the system before we create a new partition, although it's not entirely clear to me if we actually have any defects on this drive. I guess the IBM software might just have ignored it, and maybe this is why it works. So let's jump back into fdisk again and create a new primary partition. Now I can format the drive. Formatting 29.96 megs. So this is actually a pretty beefy drive for an XT clone. Okay, format complete. I also made a second floppy with scan disk and check disk from DOS622. So let's run check disk on C:. Instead of using check disk, try using scan disk. Well, if you say so. So scan disk here came with DOS version 6.2 and later. I can't recall ever seeing it in fluorescent green though, because I typically run DOS 5 or older on XTs. ScanDisk can also perform a surface scan of this drive. It will take about 20 minutes. So let's see if it will find any issues that IBM wasn't able to find on this huge RLL drive. Okay, it finished in about 5 minutes and it didn't find any faults. So I don't think this drive actually has any faults. This is some kind of weird compatibility issue. So I'm gonna see if I can find some more supposedly bad MFM drives in my stash and try them out with IBM software too. Next up I installed Checkit 2. Something. Let's do some benchmarks. Okay, put Checkit OVL in floppy drive A. Well, I actually don't want to run Checkit from drive A for a very good reason that will be apparent in a minute. So I copied all the files from disk 2 to the hard drive. Let's see if this works. Yes, it worked. Okay, so if you copy the content of disk 1 and 2 of Checkit 2.1, it will run entirely from the hard disk. And as expected, we're getting exactly the same score as the original IBM XT. Now let's see if we can make this Commodore run faster than overclocked original IBM PC. So this clone here seems to have been made from pretty much the same components as the original XT. So it's a pretty shameless clone. The clock to the CPU comes from this crystal here. It's a 14.3 MHz crystal, and divided by 3, it gives the CPU 4.77 MHz. But on these boards we can't just replace this crystal, because some parts of this motherboard can't be overclocked. So we need to overclock the CPU and leave the rest of the motherboard at original speed. So the first thing we need to do is to put the Siemens SAB8284B-P in a socket. I'll start by adding some fresh solder to all the pins. Oh, the pins on this chip have hooks, so we need to be careful with this one. When they manufacture these boards, they cut the pins off to make them shorter, and sometimes the piece that is cut off stays on the pin and forms a hook. And when you remove the chip from the board, that hook can get stuck and rip one of the pads off. So we need to make sure that we remove all the hooks before we pull this chip. The solder came off very easily, and all the hooks actually came off the pins, so they are now inside my desoldering gun. So I'm going to check and make sure that all the pins are loose before we continue. I'm just very gently going to feel if this chip is loose now. No, that chip is still stuck. But all the pins on the other side of the board are loose. So we need to use the rework station to get that chip off the board. There are some plastic parts here to worry about. So we've got the Matco socket here, and then we have this adjustable cap here. So I'm gonna be careful not to melt them. Yep, here comes our chip. And it's off the board. I still use my pine sill for through-hole components because I really like this tip. And I really hope they will make a tip like this for my soldering station too. I'll clean up my mess. Okay, next up we need to install a small PCB in the socket here to separate the CPU from this crystal here, and then install a crystal on the PCB that will give the CPU a faster clock. This is an old project that dates back all the way to the 80s, and this specific version here I think is designed by Retro Canada, but unfortunately this board here won't fit because it ends up on the power connector. This board is designed for the original IBM PC. And then we have the skinny sprint. These boards are designed by Vintage Support Service. They are specifically designed to fit in the PC, XT, PC Junior and the 5155. So basically the entire lineup of 8088 machines from IBM. And it almost works on this Commodore too. It fits well enough so we can do a test. But unfortunately it won't fit inside the case. It's slightly too long. So I'm gonna check with Vintage Support Service and see if I can use his files to make a slight modification to these boards. The only thing that needs to be done for this to work is to flip the pin headers the other way around. That way we should be able to install it like so. I'm gonna have to double check and make sure that the drive cage for the floppy will still fit. But I think that's all that's needed to make this work. But for a quick test, this is gonna be good enough. To get some clearance for J17 and this tab here, we need to install a socket in the socket to raise the sprints off the board. Now it doesn't short to J17. I'm gonna start with a 21.4 crystal This crystal here works on most IBM 5150s. So not the fastest, but definitely a speed increase. Now we can install the original 8284 in one of the sockets on the Sprint. Then we need an extra 8284 installed in the second socket. So the CPU is gonna get the clock from this crystal with one of the chips, and the rest of the board is gonna get the clock from this crystal here and the other chip. That's basically how it works. Let's hope this Commodore will cope. Okay, let's see if the Commodore PC10-II will do 7.16 MHz. Okay, posts, and it's counting up the RAM. Let's see if it will boot. We've got the pet sound, and it boots. Awesome! So the Commodore PC10-II apparently can be overclocked. Let's run check it and run the benchmarks. And sure enough, we've got a CPU speed of 7.16. That is a very nice speed increase. But that's not what we came for, is it? So let's see if we can beat the original IBM PC. The fastest speed we have achieved with the original IBM PC is 7.5 MHz with a 22.6 MHz crystal. So let's install a 24 MHz crystal on the Sprint. That is going to be divided down to 8 MHz by the 8284. Okay, the moment of truth. Let's find out if the Commodore PC10-II clone is faster than the original IBM PC. Let's flip that switch. Okay, we've got graphics and it's counting up the RAM. Come on, little Commodore. Let's do 8 MHz. We've got the pet sound. Starting MS-DOS. Haha, and it boots. I think we have a new leader. Let's confirm with check it. Passed all the tests. Let's go to benchmarks. Yes! Success! The CPU is now running at exactly 8 MHz. So we've got a new leader. Well, we know what this means. We need to get that original IBM PC up to speed. I'm waiting for some parts for that machine. So there should be a new IBM PC video quite soon on this channel. Well, I think we should try it with some software. And the only game I have on a 360k floppy is Tetris. So that is a bit of a limitation with this machine, that we only have a 360k drive. But I'll fill that drive up with some fun games for the next video. Not sure if this game runs in Hercules mode. Apparently not. I'm getting sound, but nothing on the display. So let's upgrade to CGA graphics. This isn't working. I'm just getting a cursor. I need to check those switches again. Okay, I found a fault. I had to change the switch block here. By changing one of the switches, I changed to color graphics. And now we've got an image. I also found why the system reported dual floppy drives. That was because the switches here were set to 2 drives. Now we try to boot from the Tetris disk. Okay, and it works. Okay, so apparently this game runs with CGA graphics, Tandy or EGA. So, no Hercules. Yeah, totally works. Maybe not the best test. But at least we know now it's stable enough to run Tetris. Yeah, this is totally working. I'd say this Commodore runs pretty stable at 8 MHz. So I'd call that a win for the Commodore. I realize I have been using the terms PC and XT quite loosely in this video. So to clarify things, this is an IBM PC clone, not an XT clone. It only has 5 slots, and it was never sold with a hard drive installed. I checked and there is plenty of room for a sprint, facing in the other direction. It's not even close to the drive cage. Even if you install a hard drive in the second drive bay, there is still enough room. Well, actually, maybe not. Let's check with the cable installed. Yep, that is still enough room. So even with the drive installed in the drive bay where it should be, there is still room enough for a sprint underneath. The two screw holes here line up with the hard drive, so it could be installed here without the original special drive cage, but there is nothing to hold it down on this side. Since my machine came without the second floppy drive, I'm going to install the hard drive where we found it. But first, let's remove this faceplate. But I thought I would install this beige faceplate, but unfortunately it doesn't fit. It's different from the original faceplate. Despite hours in retro bright, the front cover is still slightly yellow. So I'm gonna leave the stickers off and put it back in peroxide while I record the next video. This front panel was really stubborn to retro bright. Well, even if it's not finished, it does look much better than before. I probably have a matching faceplate that would fit this drive in storage, but that could take hours to find. And I haven't even found the display for this machine yet. Ideally, I would find one of these original drives and get this machine back to stock. And then move the hard drive to the second drive bay. I'll see what can be done about that sprint and make another video about this Commodore. As always, I'll put a link on the screen here when that video is done. Meanwhile, check out this video. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.